Today's preparation is about expected value. In engineering economics, nothing is quite certain. Bank account interest rates change, the market crashes, the business might fail. Sometimes you make more money than you expect or that you anticipate is the most likely scenario. Sometimes you make less money, sometimes you lose all your money. So if you want to make money in the long run, you need to consider all of the possibilities of different things happening, and statistics gives us a way of doing that. In particular, the expected value of a calculation, the expected value of a variable is important quantity to look at. The expected value is the sum of possible outcomes, each weighted by their probability. So in general, the expected value of some quantity C is the sum over all the possibilities of your C's, so possible values of your C, weighted by a probability that that value actually occurs. So in the context of economics, engineering economics, when cash flows are probabilistic, we might want to compute the expected net present value. We don't just calculate one net present value and say that's what's going to happen. We say, well, we have a certain chance of this net present value occurring, a certain chance of this net present value occurring, and a certain chance of this net present value occurring. And we calculated the expected value of that net present value. Alternatively, we could also look at the cash flows in a year and say we have, for each year, we know that there's a certain possibility of this cash flow, there's a certain possibility of these other cash flows, and we calculated the expected values of the cash flows, and from the expected values of the cash flows, we can compute the net present value, and that's going to be the expected net present value. So there's two ways of looking at it. If you want the expected net present value, then you can compute the expected value of the cash flow each year. So the quantity here that we'll be looking at is the cash flow in a given year. And so you have the sum of each of the possible cash flows in that year multiplied by their probability of occurring, and you get the expected value of the cash flow in a year, and then you calculate the net present value of those expected values of cash flows. Or you can compute the net present value of each possibility first. Maybe that's a little simpler. You've got a 10% chance of these cash flows, a 20% chance of these cash flows, and a 30% chance. Well, all the possibilities have to add up to 100%. So let's say we've got these possible cash flows, their probabilities add up to 100%, and we compute the net present value of each of those possibilities, then compute the expected value of those net present values. So we take the quantity in that case is the net present value, we take their possible values and we weight them by their probability of occurring and sum them up. Let's do an example. An analyst has determined the net profit of your company over the next 5 years under 3 different scenarios, each of which has a known probability. Where do these probabilities come from? We're not studying that. That's a more complicated topic, so assume that you know those probabilities. And here are those cash flow probabilities for your company. So there's a 30% chance that your business is going to go like this. In year 0, you're going to put nothing in, but you start getting 10, 11, 13, 13, 13. There's a 30% chance of these cash flows. There's a 50% chance of these cash flows, and there's a 20% chance of these cash flows. And our question is, if the minimum attractive rate of return is 10%, what is the expected net present value? First example, calculate the expected net present value of these cash flows. So remember, there's 2 ways we can approach this. We can first compute the expected value of the cash flow each year, and then we compute the net present value of those. Or we can start by computing the possible net present values, then calculate the expected net present value from that. So let's try that. Let's start with this option first. Compute the expected value of the cash flow each year. We'll start with that. So the expected value of the cash flow in year 0 is going to be the product of this possible cash flow times the 30% plus this cash flow times the probability of occurring plus this cash flow times its probability of occurring. Because these 3 add up to 100%, we should be okay there. Well, of course, since all 3 possibilities are 0, that's what we're guaranteed to get. I'm going to modify this formula a little bit. I'm going to say, I'm going to lock F4. I'm going to lock C4 and I'm going to lock D4, these probabilities, so that I can just click and drag this down the row. And so here we have the expected value of the cash flow in each year. Let's give ourselves a little bit, a few more decimal places to see that it's not exactly 16. It's not just a simple average of these things, right? If we were to calculate the average, we'd say 13 plus 16 plus 19, all divided by 3, right? Or 1/3 times 13 plus 1/3 times 16 plus 1/3 times 19. That's not what we're doing. They don't all have equal chances 1/3 of occurring, or 33% of occurring. This one has 33%, this one has 50%, this one has 20%. So that's how it differs from a simple average. They're weighted by different possibilities, probabilities of occurring. So this is the expected cash flow, and we can compute the net present value of that. So let's get our discount factor. And the discount factors in our case are, we have a 6% interest rate, I think. Maybe it's 10%. 10% is the interest rate. So the interest rate is 0.1. So let's calculate those discount factors. 1 plus 10% to the negative year. And our expected present value then is the is the present value of the expected cash flow. So it's the discount factor times the cash flow, and then we just calculate the net present value of that as before, and it turns out to be the expected net present value. We just sum over these. 51.13. So let's see how we can get it in a different way. The other way that we can do it is we can compute the possible net present values, then calculate the expected net present value. So let's calculate all 3 possible net present values. So I'm going to get my discount factor. I'll put that over here. Let's just create it again. Discount. Okay, so let's calculate each of the possible net present values. So the present value of the cash flow with this first case, I'll calculate this possibility, is the discount factor multiplied by the cash flow in that year. Okay. Now let's lock this column here, B13, so that we'll be able to just drag that over. So that when we drag over, we've got the other possible cash flows. Oh, something happened. It looks like I wanted to also lock this this column here. Oops, I actually messed up. So I want to lock this column. I want to lock the discount factor column. I want to leave the cash flow column unlocked, actually. Yeah, I want that to drag with me. All right, so I'll drag that over. Much better. Okay, so let's check that this is correct. The discount factor multiplied it by that cash flow. Okay, so here are my 3 different possible cash flows over the years and their present values of them. And so from that, I can calculate the net present value of each possibility. It's just the sum. And finally, I can calculate the expected net present value is this net present value multiplied by its probability of occurring plus this net present value times its probability of occurring plus this net present value times its probability of occurring. And we get the same answer as we do above. It doesn't matter which order that you do it in. Should mention that there's a little bit more compact way of doing this. When we've got lots of possibilities, you don't want to have all these extra columns. So a much more compact way of calculating the net present value is the SUMPRODUCT function. So the SUMPRODUCT function in Excel does exactly what you need to do to calculate net present value. You can take one column and then you multiply each individual element You don't actually have to include the multiplication. You say select one column, and you're going to take the product of corresponding elements out of this column and that column. Each of the products is calculated just like they were calculated here. You calculate the products of those things, and then it's going to sum over all of them. So I'm going to close it, and I'll find that my first net present value is the same here. So this is replacing, this single cell replaces this whole column. So it's a little bit more compact. And let's see, we want to hold the discount column fixed as we move over. We can drag this over and it'll follow us. So in each case, so let's see more decimal places to make sure that they agree. Yep, we're getting the same answers in either case. Okay, so that's another way that you can do it, a little bit more compact. And the expected net present value, well, we can use sum product here in a different way. We're going to take the sum product of these possibilities and these net present values. And we get the same thing as we did over here. So just a little bit more compact way of doing it. We're still calculating, effectively, we are calculating the net present value of each possibility and then taking the expectation of the net present values. But this is just a more compact way that avoids having to create actually all of this stuff. We've just added a few more cells. Okay, so the next problem. Flood damage in a given year is given according to the following table in some other situation. We've got a 75% probability that there's not going to be any damage, and we've got a 25% probability that there's going to be some sort of damage. 20% probability that there's $10,000 in damage, 4% probability that there's $20,000, and only a 1% probability of that high damage level. What's the present worth of flood damage for a 10-year period, or the expected, I should have said, the expected present worth of the flood damage for a 10-year period? Use 6% as the effective annual interest rate. Okay, so we'll actually do this one by hand. Here's our problem. So this one here, again, we've got two possibilities. We can first calculate the Okay, so let's I think it'll help to look at this in terms of cash flows and see what this table is telling us. So there's always those two possible ways of looking at this. What we could do is calculate the expected cash flow for each year, and then we could compute the net present value of those expected cash flows. And I think that that's probably the way that we might want to proceed here, is calculate the expected cash flow for the year, and then calculate the net present value of that. So we've got a 75% chance that cash flows are going to look like, here's our line, from 0 to, we've got a 10-year period, and we've just got nothing, no cash flows, so nothing. There's a 20% chance that the cash flow in each year looks like 10,000, so a little bit. There's a 4% chance that the cash flow is bigger in each year. And then there's a 1% chance of the cash flow being really big. Well, I should be careful here. Let's put the 0 over here. And this is year 1. Because annuities always start in year 1. I should mention that the diagrams are a little bit misleading. It's not like we have a 75% chance that every year is going to have 0% zero cash flow, a 20% chance that every year is going to have $10,000 cash flow. It's really individual years can have these different probabilities of different cash flows, but for the sake of our analysis, it turns out it's not going to matter. So we're going to draw it like this. So I think there's two ways we could do it. We could calculate the net present value of each of these and then take the expectation of those, or we could take the expected value of the cash flow in each year and then we could find the net present value of that. I think it's probably going to be easier to do the expected value. Well, let's do it each way. All right, so let's do it the first way. We're going to take the expected value of the cash flow in a year. the expected value of the cash flow of basically of the annuity that we're going to have is 0.75 times 0 plus we've got a 20% chance 0.2 times 10,000 plus, we'll do this in thousands, 0.04 times 20,000 plus 0.01 times 30,000. And so the expected value of the annuity that we have is $3.1,000. And then we can calculate the net present value of that. The net present value of the expected annuity is the expected net present value. So it's the expected value of the annuity. We want to calculate the net present value of that. We get the P over A factor for, we've got a 10-year period and a 6% interest rate. So this here is just that 3.1. This discount factor is 7.3601. And the product of those two things is $22,816. So that's the expected net present value of the flood damage. And I guess we should probably say that this should all probably be negative because damage is probably going to be a cost. But that's the same idea. To within a sign, that's what we want. Another way we could do this is we could take the expectation of, or scary, we'd take the net present value of each of these. So the net present value in this case is equal to, well, we've got 0, right? The net present value in this case is $10,000 multiplied by our discount factor, 7.3601. And that's 73.61. Let me try to clean up my handwriting. That I do not have. I am not as good as Sal Khan at this. Alright, that's my best. The net present value of this case is 20 times our discount factor is 147.2. And finally, the net present value of this scenario is 30 times our discount factor is 220.8. So the expected net present value is, we've got a 75% chance of 0 plus a 20% chance of 73.6 plus we've got a 4% chance, 0.04 times 147.2, and we've got a 1% chance of 220.8. And we get the same answer as before, 22.816 $1,000. So I'll turn that point into a comma. Same answer either way.